Ceres. Ceres is the only dwarf planet in the inner solar system, orbiting inside the asteroid belt between Mars and Jupiter. It is roughly 940 kilometers across and contains about a quarter of the total mass of the entire asteroid belt. When Giuseppe Piazzi discovered it in 1801, it was classified as a planet. It was demoted to an asteroid decades later, then reclassified again as a dwarf planet in 2006. Approximately a quarter of its mass is water ice. The Dawn spacecraft orbited it between 2015 and 2018 and found bright deposits inside a crater made of sodium carbonate, left behind when briny water reached the surface and evaporated. This suggests liquid water still exists beneath the crust. Pluto. Pluto is roughly 2,377 kilometers across and takes 248 years to complete one orbit. Its path is tilted and elongated enough that it periodically crosses inside the orbit of Neptune, though a stable 3:2 orbital resonance ensures the two can never collide. It has 5 known moons. The largest, Charon, is more than half Pluto's diameter, and the two bodies orbit a shared center of gravity that lies outside Pluto's surface. When New Horizons flew past in July 2015, it revealed nitrogen ice glaciers flowing across a vast basin called Sputnik Planitia, mountains of water ice up to 3.5 kilometers tall, and a thin nitrogen atmosphere. Surface temperatures reach minus 230 degrees Celsius. Eris. Eris is slightly smaller than Pluto in diameter, but roughly 27% more massive. It was discovered in 2005, and its discovery is the direct reason the definition of a planet was rewritten. Astronomers faced a choice: either accept Eris as a 10th planet or create a new category. The International Astronomical Union chose the second option in 2006, and Pluto was reclassified alongside it. Eris takes 559 years to orbit the Sun and travels out to roughly 97 astronomical units at its farthest point. Its surface is coated in methane ice that reflects about 96% of incoming sunlight, making it one of the most reflective objects in the solar system. It has one known moon, Dysnomia. Makemake. Makemake is roughly 1,430 kilometers across and orbits in the classical Kuiper belt, taking about 305 years to complete one circuit. It was discovered in 2005 and named after the creator deity of the Rapa Nui people of Easter Island. Its surface is dominated by methane ice, similar to Pluto and Eris. When it passed in front of a background star in 2011, astronomers expected to detect an atmosphere and found none, which was unexpected given that Pluto maintains one at comparable distances. A small moon was discovered in 2016. That moon reflects only about 4% of the light that hits it, making it dramatically darker than Makemake itself, a contrast that remains unexplained. Haumea. Haumea is not spherical. It is a stretched ellipsoid measuring roughly 2,100 kilometers along its longest axis and only 1,100 kilometers along its shortest. The distortion is caused by its rotation. It completes one full turn every 3.9 hours, faster than any other large body in the solar system, and the resulting centrifugal force pulls it out of round. The spin is most likely the result of an ancient high-energy collision, which also produced a family of icy fragments that still share its orbital path today. It has 2 moons, Haumea and Namaka. In 2017, astronomers detected a ring around it, the first ever found around a trans-Neptunian object. Gonggong. Gonggong is roughly 1,230 kilometers across and follows a highly elongated orbit that takes about 550 years to complete. It was discovered in 2007 but not formally named until 2019. Its surface is deeply red, produced by tholins, complex organic compounds that form when methane ice is bombarded by ultraviolet radiation over long periods. Water ice detected on the surface suggests it may have supported a subsurface ocean earlier in its history. Its rotation is unusually slow at around 22 hours, most likely because tidal interaction with its moon Xiangliu has been gradually draining its angular momentum. It is among the largest objects in the solar system without an official dwarf planet designation. Quaoar. Quaoar is roughly 1,090 kilometers across and was discovered in 2002. In 2023, astronomers detected a ring around it, and the ring is in a position current theory says should be impossible. It sits at roughly 7 times the radius of the body, far outside the Roche limit, the boundary within which tidal forces prevent material from clumping together. Beyond that boundary, ring particles should have coalesced into a moon within decades. Instead, the ring is stable. The discovery forced a re-examination of how planetary rings form and persist. Quaoar's surface shows crystalline water ice and ammonia hydrate, both of which suggest cryovolcanic activity resurfaced it at some point. It has one moon, Quaoar. Sedna. Sedna is roughly 1,000 kilometers across and follows one of the most extreme orbits known in the solar system. Its closest approach to the Sun is 76 astronomical units, far beyond Neptune, and its farthest point takes it out past 900 astronomical units. A single orbit takes approximately 11,400 years. Because it never comes close enough to Neptune to have been thrown into that path, its orbit cannot be explained by any known process. The leading candidates are a close passage by another star early in the solar system's history, capture from a different star system entirely, or the gravitational influence of an undiscovered massive planet in the outer solar system. It is also one of the reddest objects known. Orcus. Orcus is roughly 910 kilometers across and locked in the same 3-2 orbital resonance with Neptune that Pluto occupies. The difference is timing. When Pluto is at its closest point to the Sun, Orcus is at its farthest, and the two are always on opposite sides of their shared resonance pattern. For this reason, it is often called the anti-Pluto. Its moon Vanth is roughly 475 kilometers across, an unusually large fraction of the primary body, which suggests the pair formed through a collision rather than gravitational capture. Water ice and possible ammonia, compounds on the surface, point to cryovolcanic resurfacing at some point in its past. Salacia. Salacia is roughly 850 kilometers across and was discovered in 2004. Its surface reflects only about 4% of the light that reaches it, making it one of the darkest large objects in the Kuiper belt. Measurements of its mass and volume give it a lower density than most comparable bodies, indicating it contains proportionally more rock and less ice than objects like Pluto or Haumea. This matters for its classification. Whether Salacia has enough internal mass to have pulled itself into hydrostatic equilibrium, the requirement for dwarf planet status, is not resolved. It has one moon, Actea, which is unusually large relative to the primary, at roughly a third of its diameter. Varuna. Varuna is roughly 680 kilometers across and rotates once every 6 1/3 hours. The rapid spin has stretched it into a visibly elongated shape. Its measured density is close to 1 gram per cubic centimeter, near that of water ice, which is low enough to suggest it is not a solid differentiated body at all. The most likely interpretation is that Varuna is a porous aggregate, a loose collection of ice and rock held together weakly by gravity, with substantial empty space between the fragments. If that is correct, it does not meet the hydrostatic equilibrium requirement, and it would not qualify as a dwarf planet under the current definition. Ixion. Ixion is roughly 620 kilometers across and shares the 3-2 orbital resonance with Neptune that defines the group of objects known as Plutonos. It was discovered in 2001. Its surface is moderately red, consistent with the presence of processed organic compounds, though it is less extreme than objects like Sedna or Gonggong. No moon has been confirmed, which removes the most direct method of determining its mass. Without a mass measurement, its density and internal structure remain poorly constrained, and whether it has compacted into a stable rounded shape is unknown. It sits near the lower size boundary of objects still considered plausible dwarf planet candidates. Thanks for watching. Should Pluto still be a planet? Let us know what you think in the comments down below. Also, please remember to like and subscribe if you enjoyed this video.